Hello everyone, and welcome to my basement. Today we're going to be looking at this wonderful thing, which is a 20-watt hand-cranked powered electrical generator. It's being sold under the guise of being used for camping or for emergency power production for a variety of reasons. Of course, it has a very long and sort of rambling descriptive title, but we're going to see if it actually lives up to any of the claims that are made in the description for this product. So it claims to be able to output 20 watts, max power 20 watts, but then it also says voltage current 3 volts 6.6 amps, 5 volts 4 amps, 6 volts 3.3 amps, 9 volts 2.2, 12 volts 1.6, 15 volts 1.3. Well, mathematically, those all also work out to 20 watts, which doesn't really make sense because if you're doing any kind of voltage regulation, there is going to be loss involved. So it's questionable whether or not this device is actually going to do everything that it claims. Generally speaking, in terms of construction, it's really not bad. It's an all-metal enclosure. It has screw-on rubber feet instead of little adhesive mount ones, which is great because the adhesive mount ones tend to slide around and fall off and leave a slime trail on the bottom of whatever they're on. And they are soft, so I mean it does stay in place pretty well. I do see deficiencies right off the bat, namely the terminations for your power outputs here. I have a feeling these are like antenna input jacks for the back of a radio or something because they're really lightweight. But we're only talking about 20 watts, so I could see 20 watts being okay with connectors like this. The other thing that I noticed when I was unboxing it and putting it together was that the weld that holds the shaft of the handle onto this collar that goes onto the input is really not a good weld at all. It's very, very poor quality, and it's been poorly finished, and you can see right through this plating they put on it. Also, the shaft mounts with a through bolt. There's a bolt here with a nut on it. I would think if you were going to take this thing camping or something that you would want to take this handle off so it would store smaller for transportation. And I think there's a pretty high risk of this nut getting lost, and then you can't use it at all. It would be better if it was a splined shaft or if it had a keyway or something like that. But you can't win at everything. Purchase price for this, I paid $30 US, delivered from China. I've seen this for sale from other locations besides where I got it. There's a link in the description to a general search for where to find these things. I don't want to link to a specific item because I don't want the seller of that item to find out that it's being linked to and then raise the price on it. Interestingly enough, it came in this box, which is from Goso Technology, Zhongshan City Goso Electronic Company Limited. But what's weird about this is this company doesn't exist. The website gives a 404 error. The phone number isn't in any directory, and I don't speak Chinese, so I don't know what that is. It seems to be a nice little thing, and we're going to take a look and see what it does right now. Okay, back. I've been screwing around with this for a while now, trying to figure out the best way to actually calculate the capacity of this thing, and it's proving to have some faults when it comes to how much power you can actually get out of it. So right now I have this set in 3-volt output mode, and I have this meter showing the output voltage, this meter showing the output current, and these 3 big sand resistors add up to a half an ohm. So at 3 volts, a half an ohm, approximately a half an ohm, should draw 20 watts. But it doesn't. So let me crank this up. So the best I've seen it do is about 2.3 amps. You know, but it peaks, which is weird. I'm trying to turn this about as hard as I can here, and we get, you know, just over 1 volt and about 2.3 amps. That works out to be 2.6 watts. So 3 volt output driving into what should consume 20 watts is really only producing 2.6. So that's a little bit of a downer. Now I'm testing it at 5 volts, and I have this set up in a little less nausea-inducing way. So what I have is 3.9 ohm resistors in parallel, giving me an ohm and a quarter. 1.3 ohms, more or less. And I've got the device set for 5 volts. And let's see what this does. Okay. Well, that looked an awful lot like 1.9 amps, which, again, is not really 20 watts. 1.9 amps into 1.3 ohms is 4.6 watts. So now we're driving 1.9 ohms, consisting of a 5.6, a 5.6, and a 5 ohm resistor in parallel, using the 6 volt output of this, which comes to approximately 20 watts. Let's see if that does better. Oh, okay. I'm starting to think that this thing has an actual current output limit of about 2 amps. Some piece of circuitry in here won't do more than 2 amps of anything. I'm sorry, I gave you bad information. That was 1.79 ohms, and 2 amps gave 7.16 watts. So it is improving. Okay, now we're driving from the 9 volt output into 4.2 ohms. The handle's gotten real jumpy. Like, if I turn it too fast, it's like it's over-spinning. So we got, what, 1.5 amps? Give them the benefit of... we'll give them the benefit of the doubt and say 1.6, because it's kind of all over the place. So that made 10.75 watts on the 9 volt output. Okay, I have the 12 volts set up to run through 7.7 ohms. It's considerably easier to turn the handle now. Like, much, much easier. So I see that peaking 1.38 amps. Okay, now we have 11.6 ohms in the form of a 5.6 and a 6 ohm resistor in series. And this is set up on the 15 volt regulated output. Okay, I see 1.22 amps. Okay, so driving through there, I got 17.26 watts, which is getting close to the rating, but still not there. So now what I'm going to do is I'm going to try driving through 12 ohms on the unregulated output, the one that's not got an output selectable by that switch on the front. So all I'm going to have to do is switch this over to here, and we'll see what happens through that 12 ohms. Jeez. Okay, so turning that as hard as I possibly could, I got about 1.3 amps going through that 12 ohms. So that's 20.28 watts. And that's about as hard as I could possibly turn that, about as fast as I could possibly turn it. So yes, you can get 20 watts, but you're not really going to get it in any kind of terribly useful way. I think before we talk about philosophy on this thing, we need to talk about the scientific data that we just collected. So I've prepared a spreadsheet with all of the information that we know and all the information that we've learned. So what we started out knowing was that this thing was supposed to output 3, 5, 6, 9, 12, 15 volts. And the manufacturer claimed current outputs. I did the math. Volts times amps equals watts. So they claimed that on each one of the outputs, it was going to make approximately 20 watts. And we can infer from their total overall rating that the unregulated output should then be 20 watts. Now, I calculated the theoretical resistance that you would need in ohms in order to dissipate 20 watts from each of these voltages, which wound up being these values. These are the actual values that I used because it's as close as I cared to get in terms of putting resistors in parallel and series and doing calculations to figure out what the final resistance would be. But you can see they're pretty close all the way down the line. Now, you watched me measure how much current was flowing through those resistors, which was significantly less than what the manufacturer claimed it would be all across the board. Now, volts times amps equals watts, but in this case, watts equals current divided by resistance. Never mind if that's wrong or not. Look it up. So we found that they claimed 19.8 watts on the 3-volt output. Best I was able to do was 2.65, which is 13% of what the manufacturer claims that the output is. I'd like to see somebody turn that handle enough to make 20 watts if the best I can do is 13% of the claimed value. Now we notice that the switcher that's in here, the switch mode power supply, is more efficient if the input and output voltages are closer to each other. So as we go up in voltage, we also go up in relative percentage to what the manufacturer claims. All the way up to, on the unregulated output, 101% of their claim. So saying that it's 20 watts they can get away with because I can make 20 watts come out of this thing. But you're really not going to want to use you're not really going to want to use an unregulated output for anything, really, because the voltage is all over the place coming straight out of the motor that's being used as a generator inside this. It's not entirely without use, though. You would probably do pretty well using the unregulated output to charge a lead-acid battery, because lead-acid batteries are very tolerant of input voltages as long as it's reasonable. You're not trying to jump it with 120 volts. But if you put 15, 18, 19, 20 something volts at this low power rating into a 12 volt battery, it'll just soak it up and do just fine. 15 volts, I don't really know what 15 volts is for. We're getting into the philosophy of this device. I don't know what 15 volts is supposed to do. 12 volts, obviously, anything that plugs into your car, anything that uses 8D batteries is going to use 12 volts. 9 volts, anything that uses a 9 volt battery. Perfect. 6 volts, anything that uses 4 alkaline cells. It'll work fine. 5 volts, obviously USB power. Anything that uses 3 alkaline cells will be fine with that. 3 volts, anything that uses 2 alkaline cells. And that starts to get into where are you going to want to use this? They're talking about camping and emergencies. Let's look at camping. You really need to have this thing on a very stable surface, and it needs to have a sharp edge on it because the feet are so close to the front of this thing that you can't really hang it over the edge of whatever you're working with. It just doesn't work very well. So if you're going to take this thing camping, you really have to have a solid surface that you can hang this thing on the edge of. And a couple of times in testing, I slammed the corner of this into the table, and when you've got force behind what you're doing, that hurts. And basically you have to do this, like at a picnic table or something, stationary. And in terms of charging, let me see if you guys can see this or not, because I don't know if you guys can read that little screen. I'm thinking probably not. Okay, so I have hooked up to this. Hello, focus. Okay. So you can see the meter there. So it says I'm making 4.5 volts, 0.77 amps. And what I have this hooked up to, and it's quite easy to turn, so there's really no fatigue involved in doing this part. What I've got hooked up here are two USB power packs and this goofy LED fan thing that is just because this would be really boring if there was nothing making lights. If I've got two of those power banks that aren't fully charged, and all I can put into them is 0.77 amps, because the voltage output is not fully 5 volts, it's going to take forever to bring these things to a full charge. I mean, if I could charge at 2 amps, that'd be great, but, you got to remember, it's only 2.6 watts. You'd be there forever trying to charge your phone at that rate. So if you see down there at the bottom of that little display, it shows you the amount of milliamp hours that you've expended, which is pretty cool. And you can see that is ticking up just so slow. It's awful. So this thing for camping, I don't know what you'd use it for in the context of camping. I just don't see what it would be for. It's a really rather inefficient way to charge batteries. How much of your camping trip do you want to spend? How much of your weekend or your paid time off do you want to spend turning this crank? And for me, the answer is absolutely none of it. 0 hours. And charging your phone is going to take an hour of turning this crank. It's not worth it. Get a solar panel. Get a solar panel and a battery bank that has a good, actual boost converter in it, so it really gives you 5 volts out. And your phone will charge in the same amount of time that it takes to charge it at home. Just leave the thing, hang it on your tent, stick it on a tree, leave it somewhere. Nobody's really going to take it. Unless camping, I think its usefulness is just 0, as far as I'm concerned. However, there are applications where I think this would do really well, and it's the emergency situation, particularly with the set of outputs they've given you. Because you can run basically any low voltage, low current device with this. This little fan is kind of a ridiculous appliance to have, but, it does work. I don't know what you would do with this fan in an emergency other than look real cool, but, it could serve any purpose, really. I suppose this thing finds its ideal niche in that sort of dystopian future where there are no batteries at all anymore. They've all died. because you could run other weird things. I'm going to try and set some of that stuff up now and see if we can actually power any of the stuff that I hope we can. As far as where this thing could get used in an emergency situation, lighting is the first thing that comes to mind. So I'm going to dim the house lights here a little bit and take a look at what this does. So this is a 6-watt, it's a 6-watt LED lamp, 12 volts, made to go into halogen fixtures. I think that produces kind of a fair amount of light, for an emergency situation. I think that's fine. Yeah, that's okay. And if you're under 30, you have absolutely no idea what this is. This is authentic vintage imitation street glow. Yeah, before there were LEDs, you actually put neon underneath your car. And that's all you got. So that works, for whatever that's worth. I just have a cigarette lighter socket hooked up to the 12-volt output. And yeah, it runs both at the same time. It's a little jumpy. I'm wondering if whatever capacitor they're using to absorb the voltage is just, I don't know, if that's something seems underrated in here, I guess is what I'm saying, or overrated rather. But it is working. The other thing that came to mind was I have this sort of odd thing here. This is a 12-volt DC compact fluorescent lamp. It's made for RVs and boats and things like that. And that seems like it should be, exactly equivalent to a regular 13-watt CFL. Because, the ballast inside is doing all of its own inverting and stuff like that. So this should be exactly the same. No, that's weird. It's like it's not working. Is it? There's no on-off switch. It's wired direct. I'm going to go to 15 volts. Maybe it's expecting like 13.5 volts like you'd get from the alternator in a car when it's running. That's not doing anything at all. Well, why is that? Why is that not doing anything? They're in here, the right polarity and everything. You know what I bet's going on? I bet this... See, that's part of the problem with this. It's not efficient for charging batteries. And you're missing out on the ability to handle anything that needs inrush current. So, like, you would have a hard time using this thing near its rating with a motor or with a light that requires a kick of amperage to get it on. I don't know how to get that thing to turn on. Well, here, let's give it all we can give it by hooking it up to the unregulated input. Because if it's made to hook up to a vehicle's electrical system, it should be able to handle a relatively unregulated input. We got nothing at all. Okay. I just have a 12-volt lead-acid battery here. Okay, well, that lights right up. So, obviously this thing just can't do the inrush current. What if we added a big cap in parallel? I wonder what that would do. Let's try that. Let's try a big capacitor. Okay, this thing is ridiculous. It really needs some kind of a clamping mechanism to hold it down, because trying to get this bulb to light, I really needed 3 hands. So I've got it just electrical taped onto a piece of 2x4 that I have a bar clamp holding down to the table. This capacitor is going to be storing some current for me to handle the inrush requirements of the lamp, and I just have to just flip the switch on this manually here. So, all right. Oh, it almost did it. Yes, there it goes. There is 13 watts of compact fluorescent brilliance. All right. But yeah, it needs something to hang on to some current in order to let the lamp light, because the lamp probably needs more than the 19 watts or whatever that we can get from this thing in 12 volts just to get over the hill and click on. Well, that's interesting. Let's try something else. I also have something else you might find useful in an emergency situation. This is another one of those things where if you're under 30, you might have no idea what you're looking at. This is a Citizens Band radio. So a Citizens Band radio allows you point-to-point communication. You don't need infrastructure in order to use this thing. It'll just go to anybody else who's got a similar radio operating on the same frequency as you. And I don't know what the current requirements of this thing are, but we should be able to get this to turn on, I would think, with what we've got here. So, let's see. Okay. Okay, so, interesting fact, you can't use this thing for any kind of radio. Okay, so here's my microphone, here's this thing. Okay. You're hearing the same noise. You know, you're hearing the commutation of the DC motor inside the generator over the radio. So this thing is completely unfiltered. It's as noisy, if not noisier, than this thing. Let me go get something AM/FM so we can see what it does with that.
SPOT.
Okay, this makes this a complete fail for me. You're listening to an AM radio.
First order. That's business meetings in an office or a restaurant are so 2017. The hot spot now is on a treadmill. I'm Jeff Paulson of Fortune Magazine with the Fortune Business Update. The trend apparently began in the entertainment and media relations industries, and now big banks are getting on board.
Okay, I think that kind of seals it for me, really. If you can't listen to a radio that's being powered by the device because it's belching an incredible amount of EMI everywhere, I don't know. I don't know if I can really get behind that. So I guess on the whole, it's really not going to be useful for camping. Its emergency, like, end of the world kind of usefulness, I think is there. But obviously I can't use it for radio communications. I can't broadcast because all of that, warbling and hiss and stuff is all going to be on the output. And that's just not cool. It's really, I don't know. My interest in this is kind of waning. For $30, you're getting a lot for $30. But in terms of, is this going to save your life someday? I can't say it is. I guess I'm going to have to make this a no recommendation. I'm going to go through it. I'm going to take it apart. I'm going to look at the circuitry, and I'm going to see if I can't figure out a way to make this thing better, to see if I can silence that EMI somehow, to see if I can get better performance at low voltage. But as it ships from the factory, I mean, you watched the video. You saw what it can do. I don't think it's worth it, but, please feel free to tell me different if you think otherwise. Well, catch you later.